Blockchain is often sold as magic internet money or pure speculation. In this module, we treat it very differently, as infrastructure for trust in high-stakes systems like subsidies, land records, and pharmaceuticals. We'll look at where blockchain truly adds value, where it doesn't, and what it takes for governments and enterprises to deploy it responsibly. When many people hear blockchain, they picture hype, anonymous users, speculative coins, and nobody accountable. For governance and business, that's not the real promise. The real value is a shared, tamper-evident record between many parties, where no single actor controls the data, yet everyone can be held responsible for their actions. This blend of decentralization, verifiable transparency, and clear accountability is what improves ease of doing business and ease of living. To decide whether blockchain is worth using, start with 4 quick questions. 1. Do multiple independent stakeholders need to coordinate on the same data? 2. Is there a strong need to reduce intermediaries or middlemen? 3. Do you require a permanent tamper-evident record that all parties can trust? And 4. Do several organizations need shared, right access to that record? When all 4 answers are yes, you have a strong defensible case for blockchain. Fertilizer subsidy is not a minor exception. It's a massive cash flow of nearly 80,000 crore rupees in a single year. When reimbursements take months, manufacturers' capital gets stuck. When nobody sees stock in real time, inventory quietly leaks out of the system. And when data is scattered across departments, every reconciliation turns into a dispute. This mix of delay, opacity, and fragmentation is exactly where a trust-by-design system becomes critical. Before blockchain, every fertilizer shipment triggered a long manual paper trail. A factory dispatched goods and then waited while paper challenges moved through office after office. Each step needed physical verification, signatures, and re-entry of the same data into different systems. Only after retailers reported sales did another round of audits begin, again largely manual. Every handoff added delay, errors, and new opportunities for fraud, leading to months of capital lockup and almost no real-time visibility. The core idea in the new approach is simple. Replace that slow paper trail with a shared digital ledger everyone can trust. Manufacturers record production once on the ledger. A smart contract then tracks every transfer to warehouses and retailers. As goods move, automated checks verify quantity, destination, and Aadhaar-based identity in real time. When a genuine sale is logged, the contract immediately triggers the subsidy payment, sharply reducing delays, disputes, and fraud risk. Blockchain only earns its place if it delivers measurable outcomes. In the fertilizer subsidy case, the shared ledger cuts shipment acknowledgements from days to minutes, freeing working capital. Real-time visibility shows stock at each point in the chain, so leakages and artificial shortages are exposed quickly. And because records are tamper-evident, paper-based disputes and common fraud patterns are largely blocked. In effect, reconciliation becomes automatic, because every party relies on the same digital source of truth. Land records are another classic trust problem. Paper deeds can be lost, forged, or quietly altered, and disputes can drag through courts for years. A blockchain-based property registry replaces this with one shared history of every sale, mortgage, and charge on a plot. Entries can be appended, but not silently edited later. Even complex rights, such as transferable development rights, can be tokenized, traded transparently, and audited in real time on the same underlying ledger. The same trust paradigm applies to medicines. Each batch receives a unique digital identity at the API manufacturer. As it moves to the formulation plant, wholesaler, and pharmacy, every handover is written to the blockchain, while IoT sensors continuously record storage temperature. At the end, the patient can scan a code to verify authenticity and see the product's journey. This creates end-to-end provenance, making it extremely difficult for counterfeit drugs to enter and persist in the supply chain. Enterprise blockchain is not a standalone island. It sits as a four-layer stack. At the base, your existing ERPs and databases remain the primary systems of record. Above that, integration adapters sync, validate, and clean data. The blockchain layer then provides a shared, tamper-evident ledger between organizations. On top, web and mobile applications turn that trust into practical user experiences. The principle is straightforward: garbage in, garbage out. If inputs are wrong, the ledger will faithfully preserve the mistakes. Security in this environment follows a zero-trust mindset. Treat every request as potentially malicious, even inside the network. In practice, we keep verifying three things. Who is making the request using self-sovereign identity instead of shared passwords? What they are trying to change, using consensus so no single party can alter records unilaterally. And what they are permitted to do, using fine-grained access controls that separate reading from writing. Together, these controls turn blockchain into a defensible security perimeter. Running blockchain in production means security has to move up front, not be added at the end. Shift-left security brings testing, scanning, and verification of smart contracts and infrastructure into the very first commits, then continues at every stage of CI/CD. Combined with containers, Kubernetes, and infrastructure as code, this creates environments that are repeatable and auditable. The result is faster, automated Web3 releases without sacrificing the trust and integrity the ledger is meant to provide. When code directly holds money, mostly correct is not acceptable. A single bug in a DeFi contract can lock or leak millions. DeepCA addresses this with mathematical guarantees. Developers write smart contracts in DeepCA, and the compiler produces EVM bytecode along with a machine-checked proof that the compiled code conforms to the specification. Using the CoQ proof assistant, we move beyond hope and conventional testing toward verifiable correctness, making catastrophic failures much less likely. To actually realize this new trust paradigm, you usually need four kinds of support. First, consulting to choose the right use cases and align them with policy and regulation. Second, hands-on development of enterprise blockchains, smart contracts, and Web3 applications. Third, structured training to build internal capability so teams can own and evolve the solution. And finally, specialized manpower to scale, operate, and secure these systems over time. You've now seen how blockchain can shift trust away from paperwork and intermediaries toward transparent, verifiable systems. The next step is to map these ideas onto your own context. Where are your delays, blind spots, or recurring disputes? Those are strong candidates for a shared ledger and automated verification. If you'd like to explore architectures, pilots, or training for your team, reach out to continue the conversation. Together, we can start designing your roadmap for trusted digital governance.